Today we're going to talk about factors, and the factors are the numbers in um, a number model when you multiply them together that equal a product, the answer to a multiplication problem. So if we had a problem like this in the number model, 2 times 3 times 3. It doesn't have to be just 2, it can be 2 or more. 2 times 3 is 6, times 3 is 18. So we'd have 2 is a factor, 3 is a factor, this 3 is a factor, and 18 is the product. The numbers being multiplied together are the factors. The answer you get is the product. Oftentimes this year when we're working on factors, you'll be asked to find a factor pair, and that's two factors of a counting number, n, so any number whose product equals that same number of n. So in order to find those, in order to find the factor pairs, there's a number of different things that you can do. So let's say we want to find the factor pairs for the number 10. Let's not use 10. Let's use the number 6. That's a kind of the same one we used yesterday, but it's an easy one to work with. So to start, we could make rectangular arrays. So we could have one row of 6 with the number model be 1 times 6. We could have 6 rows times 1 column. So that would be 6 times 1. We could have 3 rows and 2 columns. So that would be 3 times 2. And we could also have 3 columns or 2 rows and 3 columns, which would be 2 times 3. So if we look at all of our numbers here, the factor pairs of 6 are 1 and 6 and 2 and 3. You don't write down both of them because it's the same way. And remember, we talked about the turnaround rule, the commutative property, where it doesn't matter what order they go in. So there's different ways that you can represent this, and the one that I like to use the best is, I call it a factor T. 1 times 6 is 6, and 2 times 3 is 6. And I like to go in order, putting the smaller number on the bottom. Another way that you can do this is you can do a factor rainbow. So you'd have 1 times 6 and 2 times 3 for a factor rainbow. Any way of doing this works. The rectangular arrays is the most time consuming. If you're not sure, this would be a good thing to do. If you're pretty sure, you could use one of these two methods. Like I said, the factor T is the one that I like to use the best, just because it's a little bit easier to write on your paper, a little bit easier to keep track of. So let's do one more example, and let's do 20. Now I'm not going to do the factor or the rectangular arrays for this. 20 is kind of a big number to do that with. So starting off, 1 times 20 is a factor pair of 20. 2 and 10. 3 doesn't work, so then we go to 4 times 5. And this is a good clue here, 4 and 5. As long as you keep in order, 1, 2, 3 doesn't work, you get to 4. The next number is 5, so then you know you have all of the factor pairs for 20. And again, you could do the factor rainbows, 1, 2, 4, 5, 10, and 20. And you can connect those. You don't have to use different colors, but it's kind of easy for me to do that. So 1 and 20, 2 and 10, and then 4 and 5. And I'm going to do one more, and I'm going to do 16 this time. So I've got 1 and 16, 2 and 8, 3 doesn't work, 4 and 4. Now when I do the factor T, I do put both numbers there, 4 and 4. But when I go to make the factor rainbow, 1, 2, 4, 8, and 16, I only include 1. So when we're talking about the factors of a number, you don't list the same number twice. You only list it once. The reason I do that for the factor T's, sometimes for division problems, if you have the factor T's, it helps to think about it. 16 divided by 4 is 4. So then if we connect those, 1 and 16, 2 and 8, and then for the single digit one, just put a little one over the same top. So those are the factors. Factors are the numbers that are multiplied together when you're finding a product, and they're also what we call, when we're looking for factor pairs, the two numbers that multiply together. So there's your factors. If you have any questions, make sure you let me know, and see you next time.